Welcome, traveler of the night. Tonight, we drift beyond the edge of Earth, beyond the familiar pinpricks of stars, into a place so vast, so ancient, and so filled with mystery, that even our boldest imaginations can only trace its outline. We are setting sail across the Milky Way Galaxy. This isn't just the hazy ribbon of light you see overhead on a clear summer's night. It is our cosmic home, a great spiral city of stars, dust, and dark matter, stretching 100,000 light-years across. Inside its vast arms, billions of suns blaze, trillions of planets circle, and hidden wonders whisper through the silence of space. In this journey, I will share with you 100 fascinating facts about the Milky Way, truths and mysteries that astronomers have uncovered, and secrets still waiting in the shadows. We'll explore its immense size, its swirling spiral arms, its ancient history, and the strange, almost unbelievable objects it contains. Stars heavier than thought possible, worlds adrift in darkness, and a monstrous black hole at its very heart. By the end of this voyage, you will not only know the Milky Way as a galaxy. You'll feel it as a living system, a place of creation and destruction, of silence and brilliance, of beginnings and endings. Before we begin, let me invite you. If you find peace in these journeys, if you enjoy documentaries that help you sleep, while filling your dreams with science and wonder, please consider subscribing to The Sleepy Doctor. It helps this little corner of calm curiosity grow, and it means you'll always have a place to return to when your mind needs both rest and fascination. So now let's settle in. Close your eyes if you wish. Breathe deeply. And let's wander together through 100 truths of the Milky Way Galaxy. The very first fact is simple but profound. The Milky Way is home. Every star you've ever seen with your naked eye, every constellation traced across the night sky, and our very own sun, all belong to the Milky Way. We are inside it, not outside looking in. When you gaze up on a dark, moonless night and see that faint band of light stretching across the heavens, you are looking through the disk of our own galaxy from within, peering along a crowded river of stars. The Milky Way is not just vast, it is a metropolis beyond imagining. Astronomers estimate it contains between 100 and 400 billion stars, perhaps even more. To put that in perspective, if you tried to count each star one per second, it would take you thousands of years without ever pausing for sleep. And yet, even our great galaxy is only one among billions more scattered through the universe. Our galaxy is a barred spiral, with a central bar-shaped core and long, graceful arms that spiral outward. Picture a glowing whirlpool of starlight, stretched across space. From far away, it would resemble galaxies you might have seen in photographs. Elegant spirals like the Andromeda Galaxy or the Pinwheel Galaxy. But from inside, it feels like home, an endless plain of stars in every direction, each twinkling at a potential sun with its own worlds. The Milky Way is staggeringly wide. From one end to the other, its diameter measures around 100,000 light-years. That means if you traveled at the speed of light, the fastest speed allowed by physics, it would take you 100,000 years just to cross from one side to the other. Even the fastest spacecraft humans have ever built would take millions of years to make the same journey. Where are we? Inside this enormous disk. The solar system rests on a small spur of one of the spiral arms, called the Orion Arm or Orion Spur. It's not a major arm like the Grand Perseus or Sagittarius arms, but a quiet neighborhood tucked in between. This is where our sun lives, circling the galaxy like a tiny firefly, in the suburbs of a cosmic city. At the very heart of the Milky Way lies a monster, a supermassive black hole known as Sagittarius A star. It contains about 4 million times the mass of our sun, all packed into a region smaller than the orbit of Mercury. Stars race around it at incredible speeds, like planets around a star, pulled by its invisible gravity. And yet, despite its ferocity, it is quiet. Not currently feeding much, not blazing as a quasar. A sleeping giant, hidden in the darkness. The Milky Way is old beyond imagination. Its oldest stars are estimated to be more than 13 billion years in age, nearly as old as the universe itself. When these stars were born, the universe was still young, filled with hydrogen and helium, with hardly any heavier elements. They are ancient survivors, fossils of the cosmos, still burning faintly in the halo of our galaxy. Where there are stars, there are planets. Astronomers now believe the Milky Way contains more planets than stars. That means there could be hundreds of billions, perhaps even trillions, of planets orbiting within our galaxy. Many are gas giants like Jupiter. Many are small rocky worlds like Earth. And countless more may wander the galaxy alone, ejected from their parent stars, drifting endlessly through the dark. Our Sun and every other star is in constant motion. The Sun orbits the center of the Milky Way at about 828,000 kilometers per hour. Even at that speed, one full orbit takes around 225 million years. That means during the age of the dinosaurs, the solar system was in a completely different part of the galaxy than it is today. Galaxies are not static pictures. They are rivers of motion, every star a traveler. The Milky Way is not only stars and planets. It is also filled with nebulae, vast clouds of gas and dust, some stretching across hundreds of light years. These nebulae are the cradles of new stars, glowing in soft reds and blues as stellar nurseries. Others are remnants, the husks of stars that exploded long ago, scattering their ashes into space. To look at a nebula is to see both beginnings and endings, creation and destruction intertwined. We have only just begun. 10 facts, a small handful of truths, and already the Milky Way reveals itself as immense, ancient, and filled with wonders. And yet, there are 90 more to go, each waiting like a star to be noticed. The Milky Way may seem vast in every direction, but it's surprisingly thin compared to its width. The galaxy is shaped like a pancake or a disk, only about 1,000 light-years thick in most places. Imagine a sheet of paper stretched across a football field. That's the ratio of thickness to width. Within this thin disk, stars are packed together like glowing grains of sand, layered with lanes of dust that blot out the light in smoky streaks. When we look toward the center of the galaxy, many of those dark patches in the Milky Way's band are actually these dust lanes hiding countless stars from view. Surrounding the disk of the Milky Way is a much larger, ghostly sphere called the halo. It contains some of the oldest stars in the galaxy, as well as dozens of ancient globular clusters, dense balls of stars that orbit the Milky Way like satellites. But the halo holds an even greater mystery. Most of its mass appears to be dark matter, invisible to our eyes. Though we cannot see it, dark matter outweighs all the stars and gas, shaping the Milky Way's gravity and holding it together. Without dark matter, our galaxy might not exist at all. Within the halo dwell around 150 known globular clusters. Each cluster contains hundreds of thousands, sometimes millions, of stars, bound tightly by gravity into dazzling spheres. These clusters are among the oldest structures in the galaxy, some more than 12 billion years old. To gaze at one through a telescope is to look at a miniature city of suns, each one a survivor from the universe's earliest days. They are like fossils, whispering stories of how the Milky Way first came to be. The Milky Way is not a finished creation, it is still under construction. Over billions of years, it has grown by merging with smaller galaxies, absorbing them into its structure. Streams of stars, like faint rivers, arc across the sky, the leftovers of these swallowed companions. Even now, our galaxy is feeding, pulling apart dwarf galaxies that wander too close. Every merger reshapes the Milky Way spiral, stirring its stars like ripples in water. In the far future, our galaxy faces a spectacular event. The Milky Way is on a collision course with the Andromeda Galaxy, our nearest spiral neighbor. In about 4 billion years, the two galaxies will merge, their stars weaving together in a slow cosmic dance. Though the event sounds violent, the space between stars is so vast that very few will actually collide. Instead, the galaxies will pass through each other, swirl together, and eventually form one enormous elliptical galaxy, sometimes called Milkomeda. It will be a new home, a transformed sky for whatever beings are alive to witness it. As the Milky Way devours smaller galaxies, it leaves behind stellar streams, long thin trails of stars stretched across space. These streams reveal the path of ancient galaxies torn apart by gravity. One of the best-known examples is the Sagittarius Stream, a remnant of a dwarf galaxy currently being absorbed by the Milky Way. These streams are like scars on the galaxy's body, reminders of a violent, ongoing history. The Milky Way's heart is not flat like the rest of the disk. Instead, it contains a bulge, a thick, rounded concentration of stars that swells around the central black hole. Billions of old, reddish stars crowd together here, orbiting in complex, chaotic patterns. If we could see the bulge clearly without the intervening dust, it would blaze across the sky like a brilliant golden cloud, a lantern glowing at the galaxy's core. Running through the bulge is the galactic bar, a stretched, elongated structure of stars and gas that acts almost like a highway, channeling material inward toward the galaxy's center. This bar helps fuel star formation and may even feed Sagittarius A*, the black hole. From above, the Milky Way looks not just like a spiral but a barred spiral, with this bright bar cutting across its middle like a glowing spine. Every star in the Milky Way orbits around the center, completing a circuit roughly every 225 to 250 million years. But the galaxy doesn't rotate like a solid wheel. Instead, stars closer to the center orbit faster than those farther out. This creates the elegant spiral arms we see, density waves like traffic jams of stars and gas, where material bunches up and ignites new stars. The spiral arms are not permanent structures of stars locked in place. Instead, they are waves of density, regions where gas clouds are compressed, sparking star birth. Within the arms, young, hot stars blaze in blue light, illuminating the surrounding gas. Between the arms, the galaxy is quieter, filled with older, redder stars. In this way, the spiral arms are like waves passing through the disk, leaving trails of newborn suns in their wake. One of the closest stellar nurseries is the Orion Nebula, visible to the naked eye as a faint patch in Orion's sword. It lies about 1,300 light-years away, inside our own Orion arm. Within this glowing cloud, thousands of new stars are forming, their ultraviolet light causing the surrounding gas to shine. This nebula is a small-scale example of what happens throughout the spiral arms, cosmic factories endlessly producing new generations of suns. Stars do not live forever. When massive stars die, they explode as supernovae, scattering their elements into space. The calcium in your bones, the iron in your blood, the oxygen you breathe, all were forged in the hearts of ancient stars and released in such explosions. In this way, the Milky Way constantly recycles itself. Stars are born, they live, they die, and their ashes become the seeds of new stars and planets. The galaxy is a cycle of creation. Sagittarius A** may dominate the core, but it is not the only black hole in the Milky Way. Astronomers estimate there could be millions of smaller black holes scattered throughout the galaxy, remnants of massive stars. Most are invisible, but some reveal themselves when they consume material from nearby stars, shining brightly in X-rays. These hidden giants are part of the unseen population that makes the Milky Way more mysterious than it appears. Not every planet has a sun. The Milky Way may be filled with rogue planets, worlds ejected from their parent systems by gravitational encounters. These planets drift alone through the galaxy, frozen, silent, their skies forever starless. Some scientists believe there may be more rogue planets than stars. Though they seem lonely, they are part of the Milky Way's hidden population, wandering unseen between the stars. The Milky Way contains different types of stars, grouped into stellar populations. The younger, metal-rich stars lie in the disk and spiral arms, shining bright and blue. The older, metal-poor stars live in the halo and bulge, dim and reddish. Together, these populations tell the story of the galaxy's evolution, showing how each generation of stars built upon the ashes of the last. Besides the thin, flat disk we see, the Milky Way also has a thicker disk, filled with older stars that orbit at a tilt. This thick disk may be the result of past mergers, when smaller galaxies collided with ours, stirring its structure. Though not as visible as the bright spiral arms, the thick disk is another layer of the Milky Way's complex history, a fossil record of ancient upheavals. Though the Milky Way looks calm from afar, it is seething with movement. Stars race around the center. Gas clouds crash together. Globular clusters sweep through the halo. Dwarf galaxies fall in and are torn apart. Nothing is still. The galaxy is alive, a vast ecosystem in constant flux, every object tugged and pulled by gravity's invisible hand. The galaxy recycles matter not only through supernovae but also through stellar winds and planetary nebulae. Dying stars blow off their outer layers, creating shells of gas that expand into space. These materials enrich the interstellar medium with elements, seeding new generations of stars and planets. In this way, the Milky Way is a cosmic gardener, forever planting, harvesting, and planting again. When certain massive stars die, they leave behind neutron stars, ultradense remnants. Some of these spin rapidly, emitting beams of radiation like cosmic lighthouses. These are pulsars flashing across space as they rotate. Hundreds have been discovered in the Milky Way, their steady rhythms helping astronomers study gravity, time, and even map the galaxy itself. They are like ticking clocks scattered across the dark. The most energetic explosions in the universe, gamma-ray bursts, occasionally erupt within the Milky Way. Caused by the collapse of massive stars or the merger of neutron stars, they unleash titanic blasts of radiation. Fortunately, none have occurred close enough to Earth to harm life. But their presence reminds us that the galaxy is not only beautiful, it can also be violent, its events beyond human scale. 30 facts now, and already the Milky Way has revealed itself as more than just a galaxy. It is a living system, thin and delicate yet vast, ancient yet still growing, serene yet filled with motion and violence. Each fact is like a star. Alone it shines, but together they form a sky worth dreaming beneath. Not all stars are born alone. Many begin their lives in groups called open clusters. These are loose gatherings of hundreds or sometimes thousands of young stars, bound only weakly by gravity. The famous Pleiades or Seven Sisters in Taurus is one such cluster. Open clusters slowly dissolve as their stars drift apart, becoming scattered across the Milky Way like dandelion seeds in the wind. Each star carries a chemical fingerprint. By studying starlight, astronomers can see which elements a star contains. Some stars are rich in metals, meaning elements heavier than helium. Others, especially ancient stars, are almost pure hydrogen and helium, with only traces of heavier atoms. These fingerprints allow scientists to trace the history of the Milky Way, like reading pages of a book written in light. Many of the galaxy's most active star-forming regions are invisible to the naked eye, cloaked in thick curtains of dust. These nurseries glow brightly in infrared light, which can pierce the darkness. Telescopes like Spitzer and the James Webb Space Telescope allow us to see into these hidden realms, revealing stars being born behind veils of cosmic smoke. It is as if the galaxy keeps some of its most intimate moments behind closed doors, revealed only when we learn to look with new eyes. Our sun is a solitary star, but most stars in the Milky Way live in binary or multiple systems, orbiting one another in graceful dances. Some pairs are close enough to exchange matter, creating fireworks of radiation. Others are wide companions drifting together through the galaxy. If we lived in such a system, our night sky might be illuminated by two suns, rising and setting together, or chasing each other across the heavens. While most stars orbit the galactic center in orderly paths, some are flung out at incredible speeds. These are hypervelocity stars, racing fast enough to escape the Milky Way entirely. Many are thought to have been slingshot by encounters with Sagittarius A*, the central black hole. Once expelled, they become intergalactic travelers, leaving their home galaxy forever. The Milky Way has a metallicity gradient. Stars near the center tend to have more heavy elements, while those farther out contain fewer. This is because star formation has been more intense near the galactic core, enriching the region with elements forged in countless generations of stars. The outer edges of the galaxy remain more primitive, chemically closer to the universe's early days. Beyond the visible halo lies a vast, hot galactic corona, made of thin, ionized gas. It stretches hundreds of thousands of light-years, far beyond the visible stars, and may contain as much mass as all the stars in the galaxy combined. This corona is almost invisible, but its presence is felt through its effect on galaxy formation. It is like an atmosphere for the Milky Way, vast and ghostly, almost too large to comprehend. The Milky Way is not alone. It is orbited by more than 50 known satellite galaxies, the largest of which are the Large and Small Magellanic Clouds. These dwarf galaxies are visible to the naked eye in the southern hemisphere as cloudy patches of light. They are gravitational companions, both feeding and being fed upon, slowly tugged and shaped by their massive neighbor. Stretching from the Magellanic Clouds is a long ribbon of gas known as the Magellanic Stream. This enormous tail, tens of thousands of light-years long, was torn away by the Milky Way's gravity. It is a vivid reminder that galaxies are not isolated, but constantly exchanging material, shaping each other through tidal forces. Most of the stars in the Milky Way are red dwarfs, small, cool, and dim. Though they burn gently, many are prone to violent flares, releasing bursts of radiation into space. These outbursts can be hazardous to planets orbiting nearby, stripping away atmospheres. Yet red dwarfs live for trillions of years, far longer than stars like our Sun. Long after the Sun has died, red dwarfs will still glow, keeping the Milky Way faintly alight. Just as planets have habitable zones around their stars, astronomers speculate that the Milky Way has a galactic habitable zone, regions where conditions are most favorable for life. Too close to the center and radiation levels are extreme. Too far out and there are not enough heavy elements to form planets. Our solar system sits comfortably in between, in what may be the galaxy's sweet spot for life. Though the Milky Way glows with billions of stars, the majority of its mass is invisible. Dark matter makes up perhaps 85% of the galaxy's total weight. Without it, the spiral arms would fly apart, unable to hold together. We cannot see dark matter, but its gravity is undeniable, shaping the galaxy like invisible scaffolding. It is one of the great mysteries of modern science. The Milky Way is bathed in cosmic rays, high-energy particles traveling near the speed of light. Many are born in supernova explosions accelerated across the galaxy. Though mostly harmless to us on Earth thanks to our atmosphere, cosmic rays constantly rain down, invisible messengers of the galaxy's most violent events. In 2010, astronomers discovered enormous Fermi bubbles extending above and below the galactic center. These vast lobes of high-energy radiation span tens of thousands of light-years. They may have been created by an outburst from Sagittarius A** millions of years ago, or by intense waves of star formation. Either way, they are a reminder that the Milky Way has a fiery past, one that lingers in ghostly form. The spiral arms of the Milky Way are not fixed collections of stars, but density waves like ripples in a pond. Stars move in and out of these waves, bunching up where gravity is slightly stronger, then drifting apart again. It is this pattern that creates the illusion of permanent spiral arms, though the material within them is always changing. Between the stars lies the interstellar medium, a thin soup of gas and dust. Though incredibly diffuse over the vast scale of the galaxy, it adds up to billions of solar masses of material. This medium is the raw material from which new stars and planets are formed. It is the breath of the Milky Way, faint and delicate, but essential for its life cycle. Our Sun is currently about 27,000 light-years from the galactic center, orbiting at a speed of 828,000 kilometers per hour. Each orbit takes around 225 million years, meaning the Sun has circled the galaxy fewer than 20 times since it was born. As it travels, it bobs up and down through the disk like a ship riding gentle waves. If intelligent beings exist elsewhere in the Milky Way, their night skies would look very different from ours. A world near the galactic center would see the sky ablaze with countless stars, so many that the night would never be truly dark. A world in the outer rim would see a sparse, lonely sky, with only the faint glow of the Milky Way rising like a misty band. Our perspective is just one among billions of possible views. Our galaxy does not float alone. It belongs to a collection of more than 50 galaxies known as the Local Group. This includes Andromeda, the Magellanic Clouds, and dozens of smaller dwarfs. The Local Group itself is part of a much larger structure, the Virgo supercluster, a vast web of galaxies stretching hundreds of millions of light-years. The Milky Way is one thread in this immense cosmic tapestry. To us, the Milky Way is everything, our home, our cradle, our night sky. Yet in the wider universe, it is one of countless spiral galaxies, neither the largest nor the smallest, neither the brightest nor the faintest. It is both unique and ordinary, extraordinary and commonplace. Its story is ours, but it is also just one chapter in the universe's vast and endless book. 50 facts now. We are halfway through our journey, yet the galaxy still feels limitless. Every fact is a window into another mystery, another layer of this cosmic home. To wander the Milky Way in thought is to drift through both wonder and peace, the perfect place for the mind to rest while the stars keep watch. Astronomers sometimes measure time in what is called a galactic year, the time it takes for the sun to make one full orbit around the Milky Way. That journey lasts about 225 to 250 million Earth years. Since the sun was born, it has completed only around 20 galactic years. When the dinosaurs roamed Earth, the solar system was in a completely different region of the galaxy. Each orbit marks the passage of cosmic seasons, far longer than anything we can imagine on Earth. As it circles the galaxy, the sun does not travel in a perfectly flat path. Instead, it gently bobs up and down through the galactic plane, like a ship floating on cosmic waves. This oscillation takes tens of millions of years, slowly lifting us above the starry disk, then carrying us back down through it. The motion is almost imperceptible, yet it weaves us into the grand rhythm of the Milky Way. When you step outside and gaze up, the stars you see are only a tiny fraction of the Milky Way. Most visible stars lie within a few thousand light-years of Earth, a small bubble compared to the galaxy's full 100,000 light-year span. The Milky Way's distant stars blend together into that faint, misty band across the sky. What you see overhead is just the local neighborhood of an immeasurable city of stars. Our solar system lies in a relatively calm area of the Milky Way, far from the dangerous center and far from the sparsely populated edges. Nearby, a scattering of stars keeps us company: Alpha Centauri, Procyon, Sirius, and many others. Astronomers call this region the local bubble, a cavity in the interstellar medium carved out by ancient supernovae. It is a quiet suburb of the galaxy, with enough distance from chaos to allow life to flourish. Though we speak of spiral arms as if they were fixed, they are not eternal. Over millions of years, the arms shift, fade, and reform. They are patterns, not permanent structures, like traffic jams in the flow of stars and gas. One day the Orion arm, our home spur, may dissolve while new arms form elsewhere. The Milky Way is not a rigid wheel but a living, changing river of matter. Within the Milky Way lie giant molecular clouds, enormous collections of gas and dust, some spanning hundreds of light-years. These clouds are the birthplaces of stars. Dense knots within them collapse under gravity to ignite nuclear fusion. They are cold and dark in visible light but glow beautifully in infrared, hiding the seeds of tomorrow's suns. The Orion molecular cloud is one such nearby nursery, busy crafting new generations of stars. When a star explodes, it leaves behind a supernova remnant, a colorful shell of gas expanding into space. The Crab Nebula, for example, is the remnant of a supernova recorded on Earth in 1054 AD. These remnants are not just beautiful, they are vital. They spread heavy elements across the galaxy, enrich the interstellar medium, and set off new waves of star formation. They are the jewelry of the Milky Way, sparkling remnants of destruction that create new beginnings. The Milky Way is threaded with invisible magnetic fields. Though faint, they influence the motion of charged particles and shape the structure of interstellar gas. These fields may help guide cosmic rays and influence star formation. We cannot see them directly, but their quiet presence ripples through the galaxy, another hidden thread in its vast tapestry. Though precious to us, our sun is an ordinary star by galactic standards. It is a yellow dwarf, neither the largest nor the smallest, neither the hottest nor the coolest. Yet its ordinariness is its gift. It burns steadily for billions of years, offering stability that allows life to thrive. Among billions of stars, our sun is unremarkable, and yet for us it is everything. In the last few decades, astronomers have discovered thousands of exoplanets, planets orbiting other stars in the Milky Way. These range from giant hot Jupiters close to their suns, to rocky Earth-sized worlds in habitable zones. The discoveries suggest that planets are not rare, but common. Nearly every star in the galaxy may host its own planetary family, meaning there are billions upon billions of worlds awaiting exploration. The Milky Way's disk is not perfectly flat. Instead, it is slightly warped, bent upward on one side and downward on the other, like a record left in the sun too long. This warp may have been caused by interactions with satellite galaxies or by the influence of dark matter. It gives the Milky Way a subtle twist, a reminder that galaxies are not rigid but flexible, shaped by the forces around them. Though stars may be born together in clusters, over time their orbits scatter them across the galaxy. Yet astronomers can trace their common origins by studying their motions and chemical fingerprints. These stellar families, long separated, still carry the marks of their shared birth. The galaxy is filled with such hidden lineages, like long-lost relatives spread across continents, still connected by their ancestry. Though the center of the Milky Way is the most important region of the galaxy, we cannot see it in visible light. Dust lanes block our view completely. Only by using infrared and radio telescopes can astronomers peer into this hidden realm, revealing the stars, gas, and the supermassive black hole within. To the naked eye, the galactic center is a mystery, glowing faintly behind a veil of shadow. Sometimes, stars in the Milky Way pass directly in front of others, their gravity bending the background starlight. This effect, called gravitational microlensing, allows astronomers to detect objects that would otherwise remain invisible, such as rogue planets, brown dwarfs, or dark matter candidates. In this way, the galaxy reveals its hidden inhabitants, one lensing event at a time. Though the Milky Way is calm today, there have been times when it experienced starbursts, brief, intense episodes of star formation. These bursts light up entire regions of the galaxy, filling them with brilliant young stars and clusters. They are often triggered by interactions with smaller galaxies, stirring up gas and compressing it into new suns. The Milky Way may one day burst into activity again, especially when Andromeda draws near. When the Milky Way was young, it contained almost only hydrogen and helium. Over billions of years, supernovae and stellar winds enriched it with heavier elements: carbon, oxygen, iron, gold, and more. Each new generation of stars formed with more metals than the last. This gradual enrichment allowed planets like Earth to exist, for rocky worlds require these heavier elements. We are the result of billions of years of chemical storytelling. While Sagittarius A* is the galaxy's supermassive anchor, countless smaller black holes drift silently through the Milky Way. Many are the remnants of stars long gone, their presence betrayed only when they disturb nearby material. The galaxy may contain over 100 million stellar mass black holes, each a hidden phantom, invisible yet immensely heavy. They are the silent ghosts of the Milky Way's stellar past. Scientists debate where life might flourish in the Milky Way. The so-called galactic habitable zone may not be fixed, but dynamic, changing as stars move, as metallicity gradients shift, as supernovae enrich or sterilize regions. What is habitable today may not have been so a billion years ago. The galaxy is not a static map but a living, evolving environment for life. Though silent to our ears, the Milky Way glows across the radio spectrum. Radio telescopes pick up the whispers of hydrogen atoms, the flares of pulsars, and the hum of cosmic rays. These signals paint a portrait of the galaxy invisible to our eyes. If we could hear radio waves, the night sky would never be silent. It would buzz and hum with the quiet music of the Milky Way. The Milky Way is both ancient and young. Its oldest stars remember the dawn of the universe. Its newborn stars will outlive us by trillions of years. We live in the middle of its story, at a point between cosmic beginnings and unimaginable futures. To study the Milky Way is to stand on a bridge that connects the deep past with the endless future, a bridge of stars across time. 70 facts now. Each has been a step deeper into the heart of our galaxy. The Milky Way is no longer just a streak of light across the night sky, but a vast and living story of stars, planets, black holes, and time itself. As we move onward, the galaxy will open more of its secrets, layer by layer, until we have wandered through 100 wonders of our cosmic home. The Milky Way's thin disk, where most of the bright stars and nebulae reside, is relatively young compared to the halo. Astronomers estimate the thin disk began forming about 8 to 10 billion years ago. Before that, the galaxy was thicker and rougher, shaped by early mergers. The thin disk represents a calmer era, when the Milky Way began to settle into the elegant spiral we recognize today. In the densest star clusters near the galactic center, astronomers suspect there may be an abundance of intermediate mass black holes, larger than stellar remnants but smaller than Sagittarius A star. These hidden objects could merge over time, feeding the growth of the central black hole. If true, the heart of the Milky Way may be a quiet nursery of black holes, invisible yet crucial to the galaxy's evolution. The spiral arms of the Milky Way gleam because they are filled with young, hot, blue stars. These stars are massive but short-lived, burning out in only a few million years. They shine so brightly that they light entire regions of the galaxy. Their brief existence means the spiral arms are always in motion, always replenished by new stars forming from the gas within them. In the halo of the Milky Way, astronomers have discovered stars so old that they contain almost no heavy elements. Some are made of nothing but hydrogen and helium with traces of lithium. These are fossils from the earliest days of the universe, nearly 13 billion years old. They show us what the first stars may have been like, before generations of explosions seeded the galaxy with new elements. Our galaxy itself is moving through space at astonishing speed. Relative to the cosmic microwave background, the Milky Way races at over 2 million kilometers per hour. And yet, because everything around us moves with it, we feel no motion. We are passengers on a starship so vast that its flight is invisible to us, drifting through the universe on an endless voyage. The Milky Way and Andromeda are the two giants of the local group, bound by gravity. Smaller galaxies orbit around them like satellites. Together, this group of over 50 galaxies moves as a family, bound into the larger structure of the Virgo supercluster. From afar, it would look like a tiny knot in the universe's web of galaxies, a glowing cluster drifting with countless others. Many of the Milky Way satellite galaxies are so faint that they were only discovered in the last 2 decades. These ultra-faint dwarf galaxies contain only a few thousand stars, barely glowing against the darkness. Yet they are important because they hold clues to dark matter and to the Milky Way's early growth. They are the crumbs left from the galaxy's ancient feasts. The halo of the Milky Way extends far beyond what our eyes perceive. Stars belonging to the halo have been found hundreds of thousands of light years from the center, much farther than the bright disk. These distant wanderers feel the pull of the galaxy but live on its edges, like outposts at the very frontier of our galactic home. The Milky Way's warped disk is not frozen in place. It is still moving, still twisting. Interactions with the Magellanic Clouds and streams of dark matter may be tugging on it, creating a slow ripple across the disk. Over millions of years, the warp may rise and fall, like a vast wave traveling through a sea of stars. Beyond the spiral arms, astronomers have found faint stellar rings, like ripples expanding outward from a splash. One of the most famous is the Monoceros ring, which may be the shredded remains of a smaller galaxy. These rings circle the Milky Way like forgotten echoes of ancient collisions, reminders that our galaxy has grown through a history of cosmic cannibalism. When studied in detail, the central bulge of the Milky Way reveals an X-shaped structure. This shape may be the result of the bar funneling stars into overlapping orbits. From our perspective on Earth, we cannot see the full shape directly, but infrared surveys show the galaxy's heart is more complex than a simple sphere. It is an intricate weave of stars twisted into a cosmic X. Near Sagittarius A*, stars whip around the black hole at incredible speeds, completing orbits in just a few years. These so-called S-stars are testaments to the immense gravity of the galactic core. Observing them has provided some of the strongest evidence that Sagittarius A* is truly a black hole. Their dance is both graceful and terrifying, like moths drawn to a flame they can never escape. When small galaxies wander too close to the Milky Way, its tidal forces stretch them into long streams of stars. Entire galaxies are shredded and folded into the disk, their stars becoming part of our own. In this way, the Milky Way is not just a spiral galaxy, it is also a graveyard, built upon the remains of many smaller galaxies consumed over billions of years. The Andromeda Galaxy, visible as a faint smudge in the northern sky, is moving toward us at 110 kilometers per second. Though the collision is billions of years away, astronomers can already trace its approach. The eventual meeting will transform both galaxies into a single giant, reshaping the night sky for any future observers who may still exist to see it. By mapping stellar streams around the Milky Way, astronomers can reconstruct its history, like detectives following trails of evidence. Each stream marks the remains of a devoured galaxy or cluster. Together they tell the story of the Milky Way's growth, not as a single event, but as a long series of meals, each leaving behind faint trails of starlight. Astronomers sometimes call their work stellar archaeology. By studying the motions and chemical compositions of stars, they can reconstruct how the Milky Way assembled itself. Every star is like a shard of pottery from an ancient civilization, a clue to the events that built our galaxy. Piece by piece, the past comes into focus. The central bar of stars is not just a structure. It actively shapes the Milky Way's evolution. By funneling gas inward, it triggers bursts of star formation near the core. It also helps maintain the spiral arms by stirring the disk. Without the bar, the Milky Way might look very different, less structured, less alive. In the Milky Way, stars of every imaginable age coexist. Some are newborns only a few million years old, still wrapped in their dusty cocoons. Others are ancient, more than 13 billion years old, older than many galaxies themselves. To look at the galaxy is to look at time itself, from the near present to the deep past, all glowing together in the same night sky. The center of the Milky Way glows in gamma rays, high-energy light invisible to human eyes. The source of this glow is still debated. It could come from pulsars, or from dark matter particles annihilating each other. Whatever the cause, the gamma-ray haze is a mystery, a faint whisper of secrets hidden in the heart of the galaxy. Perhaps the most poetic fact of all: the atoms in your body, the calcium in your bones, the carbon in your cells, the oxygen you breathe were forged in stars of the Milky Way. Long ago, those stars lived, burned, and died, scattering their elements into space. Out of those ashes, the sun, earth, and life itself were born. To say we belong to the Milky Way is no metaphor, it is literal. We are made of its stars. 90 facts now. The Milky Way has unfolded itself as both a vast machine and a cosmic poem. A spiral of science and starlight, violence and beauty, destruction and creation. We are nearly at the end of our journey, with only 10 more truths to uncover, 10 more steps across the starlit bridge of our galaxy. Every star is a fossil of a different era in the Milky Way's history. Some were born when the galaxy was still young and chaotic, others more recently in calm spiral arms. By measuring their ages and their chemical compositions, astronomers can piece together the story of how the galaxy has changed. Each star is a frozen moment of galactic time, glowing across billions of years so we can study the past without leaving the present. For years, simulations of galaxy formation predicted that the Milky Way should be surrounded by hundreds of small satellite galaxies. Yet we see only a few dozen. This mystery is known as the missing satellites problem. Some may be so faint we have not yet discovered them. Others may have been destroyed long ago. The search continues, reminding us that even in our home galaxy, vast questions remain unanswered. Not all stars are bound forever to the Milky Way. Some are flung outward at incredible speeds, fast enough to escape the galaxy entirely. These hypervelocity stars are often ejected when binary systems stray too close to Sagittarius A star. One star may be captured while the other is hurled away like a slingshot. These exiles travel alone, racing into intergalactic space, carrying the Milky Way's story far beyond its borders. The stars of the Milky Way are not chemically identical. Those near the center are generally richer in heavy elements, while those farther out in the disk are poorer. This metallicity gradient reflects how star formation and enrichment have progressed differently across the galaxy. It is as if the Milky Way has layers of history written not in stone, but in starlight and chemistry. High above and below the disk, faint rivers of stars arc across the sky. These are stellar streams, the remnants of ancient galaxies and clusters torn apart by gravity. The Sagittarius stream, for example, is a vast loop of stars wrapping around the Milky Way, once part of a small galaxy now mostly consumed. These streams are ghostly scars of the galaxy's cannibal past, beautiful reminders of the violence that built our home. The Milky Way is a master of recycling. Gas expelled by dying stars mixes with interstellar clouds, which then form new stars and planets. Elements forged in one generation of stars are passed on to the next. In this way, the galaxy continuously reshapes itself, taking the ashes of the dead and turning them into the seeds of the living. You, I, and everything on Earth are products of this great cosmic cycle, written into the galaxy's endless rhythm. Though we see only stars, gas, and dust, astronomers believe the Milky Way is built upon a vast halo of dark matter. This invisible substance outweighs all the visible matter combined, shaping the galaxy's structure and motion. Without dark matter, the stars would not orbit as they do. It is the unseen skeleton of the Milky Way holding everything together. And yet, we do not know what it is. The galaxy is illuminated by stars, but it is bound by mystery. In recent years, astronomers have discovered evidence of a colossal event in the Milky Way's past, the merger with a dwarf galaxy named Gaia Enceladus. The collision stirred the disk, scattering stars into new orbits and leaving ripples that are still visible today. Every star we see may carry scars of that ancient encounter. The Milky Way is not smooth but rippled, like a pond that still remembers the stone thrown into it billions of years ago. From one perspective, the Milky Way is ordinary, just one spiral galaxy among billions with no special privilege in the cosmos. But from another perspective, it is extraordinary. It is our galaxy, the one that gave rise to Earth and to us. Its ordinariness reminds us we are part of something vast and common, while its intimacy makes it precious. The Milky Way is at once everywhere and uniquely ours. The Milky Way is not finished. It is a galaxy in midlife, still forming stars but more slowly than before, still consuming small companions, still preparing for its eventual meeting with Andromeda. In billions of years, it will look nothing like it does today. Galaxies are not static. They are living systems, evolving on scales far beyond human imagination. The Milky Way we see is just one frame of its long cosmic movie, and we are lucky enough to witness this moment of its journey. And now, 100 facts. 100 windows into the Milky Way, our island of stars, our home adrift in the endless dark. As we drift to the close of our journey across the Milky Way, take a moment to feel the vastness around you. Each star we've explored tonight is a tiny lantern in a galaxy of unimaginable scale. Each fact is a thread in the story of a home that has been forming, evolving, and glowing for more than 13 billion years. If this journey has carried your mind across the spiral arms, through the stellar nurseries, along the streams of ancient galaxies, and into the quiet heart of our galaxy, then it has done its work. Let the wonder of the Milky Way settle softly, like starlight brushing across the quiet night. If you have enjoyed this gentle voyage through our galaxy, consider subscribing and joining the Sleepy Doctor on future explorations. Every subscription is a small companion on this endless journey through space and time. There are more galaxies, more stars, and more mysteries awaiting, ready to guide your thoughts into calm curiosity. As you close your eyes tonight, imagine yourself drifting among these billions of stars. Feel the slow rhythm of the galaxy, the orbit of your sun, the hum of distant pulsars, and the glow of nebulae far away yet near in your mind. Let your breathing follow the steady flow of cosmic time, and let your thoughts wander across the Milky Way, soft, quiet, and infinite. Remember, every atom in you was forged in the hearts of ancient stars. You are made of the Milky Way. You are a part of its story, and tonight you rest among its stars. Thank you for traveling across the galaxy with me. Subscribe, stay curious, and sleep peacefully beneath the sky we call home.